This is an Edexcel Ial P2, Pure Math 2 paper. It's from January 2023. Question 2 deals with a calculus problem that looks at minimum area. Right, let's take a look at the information that is given. It says in this question, you must show all working, so they don't want just a calculator answer. The brick in the shape of a cuboid with width x and length is 3 x and height is h, all in centimeters, and the volume is equal to 972 centimeters cubed. Okay. Number A. Show that the surface area is of S is this equation. So that's what we're aiming for. So we want surface area of this. It's a rectangular prism, a cuboid. So we can first just quickly look at what is the surface area. Well, surface area, we have two of these, plus two of these, two long rectangles, and then we have top and bottom, so two of these. And that's going to be our surface area. So this works out to being let's do the front. So 2 times width times height plus 2 times length times height, which is length times height is this side. And top and bottom is 2 times, we have top and bottom would be length times width. So that would be our formula that we're looking for. And we just need this, if we look at the answer here in terms of x, so we have s on the one side and x is on the other side. So if we sub in all the values we have here, 2 times width is x, height is an h, 2 times length is 3x, height is just h again, 2 times width, which is x, times by length, which is 3x. Okay. So let's get that cleaned up a little bit. So this would be 2xh, 2 times x times h. 2 times 3x is 6x, times h is 6xh. 2 times 3 is 6 again, and this time it's x times x, so it's 6x squared. Can add like terms, so we have 2xh and 6xh, they're the same, so they can be added together. Oopsie, 6 plus 2 is 8xh's plus 6x squared. But this doesn't look like our answer yet, so we're aiming for our answer to look like this. There's no h's in that, so we still have to do a step to get rid of the h. So, well, we have a volume given, and our volume amount is 972, but we also know that a volume of a rectangular prism is length times width times height. And so we can equate these two. We can say 972 is equal to length times width times height. That's the volume of a prism, of a rectangular prism, of a cuboid. So we can get h on its own. To isolate h, divide both sides by LW. So h is equal to 972 over length times width, which of course we know that our length was 3x and our width was x. So h is equal to 972 over 3x times by x, which is equal to 972 over 3x times x is x squared. And if we simplify that just a little bit further, we can simplify. If we divide 972 by 3, it comes to 324 all over x squared. Okay, so this is our h, our height, in terms of x. Let's grab our formula from where we were. We were over here. This was our formula that we had so far with the h in it. Formula for the, it was not surface area, so not an A, we probably want an S. It's total surface area. Okay, let's put in the h value here. So we're subbing in h equals 324 over x squared into our equation. And this simplifies to 6x squared. Let's just brought the 6x squared to the front. 8 times 324 is 2592. If we take these x's, it'll be 2592x over x squared. And if we timesing top by top, bottom by bottom. So 8x times 324 and 1 times x squared. And we can cross cancel one of those x's. So the final answer is 6x squared plus 2592 over x. And let's check if that is correct from our instructions. 5, yes, okay. That concludes number A. Number 2B, find ds over dx. So we have an s and wants us to find the first derivative of our formula for s. Wants us to find ds over dx. First thing I do with these sorts of questions is I change any x's in the denominator into the numerator. So x to the power of 1 in the denominator will be x to the minus 1 in the numerator. So it'll be 2592 x to the minus 1. And then to find the first derivative, if we have any function a times x to the power of n, first derivative, you say n times a, n times a, x, and then you minus 1 from the exponent, so n minus 1. So if this was y, this would be dy over dx, but now we're working with ds over dx because our equation was start with an s over dx. Okay, so let's do that. So this is S with the exponent written in the numerator. So we look at ds over dx. 2 times 6 is 12. X2 minus 1 is 1. Plus minus 1 times 2592 is minus 2592. X minus 1 minus another 1 is minus 2. We put this back in positive form. You want your exponents in positive form. It will be 12x minus, because there's plus times a negative is negative, 2592 all over x squared, as this x squared is positive in the denominator. And that's question B. Question C, hence find the value of x for which S is stationary. So we know from our calculus work that for stationary points, we let the first derivative equal to 0 and solve for x. And this will give us the value of x that we need. So we have just a little background on this quickly. That's because the first derivative is the gradient of the curve. And if we had a curve, for example, this quadratic curve, the first derivative, the gradient of the curve at the turning point, at the stationary point, which is the gradient is equal to 0 there. So at this point here, the gradient is 0. It's a standstill point. Okay. And that's why the first derivative, our first derivative is equal to the gradient of the curve at any point x. All right, so let's take a look at what we have here. So value of x for which S is stationary. So 12x minus 2592 over x squared equal to 0. First thing I need to do here is get a common denominator. And the common denominator is going to be x squared. So in order to get both terms over x squared, 12x, you'd have to times top and bottom by x squared, which was over 1 times x squared. So it'll be 12x. X squared times x is 3, x power of 3 over x squared minus 2592. It already had an x squared, so we don't need to change anything. Right, so now we want to simplify that further. Let's see, we have 12x3 minus 2592 all over x squared equal to 0. Okay. So from here, if we times both sides by x squared, well, 0 times x squared is still 0. So we cancel it out. 12 to x3 minus 2592 equals to 0. 0 times x squared is still 0. Let's take the 2592 to the other side by adding 2592 on both sides. So 12x to the power of 3 is equal to 2592. Then we divide both sides by 12 to get rid of the 12. Got x3 on its own, x to the power of 3. And to get rid of that power of 3, we cube root both sides. 2592 over 12 cube rooted. This was 216, and So the cube root of 216, but you can also leave it in this form in your calculator. So this would be x, that cancels out, and we end up with x equal to 6. Very nice even number for x to be equal to. Right. Number 2D, wants d squared s over dx squared, which is the second derivative of the function. So we have 12x minus 2592 x to the minus 2. I straight away took that x to the numerator. This was our ds over dx. Oh, that's an s. So now we want the second derivative, d squared x over dx squared. Take the axn would be changed to n times a x n minus 1. Okay, so 12x, 1 times 12 is 12. X 1 minus 1 is 0. So x to the power of 0 is just 1. So it's 12. X to the power of 0 equals 1. So 1 times 12 is 12. And then we have minus 2 times minus 2592, which is plus 2592. X to the power of minus 2 minus 1 is x to the power of minus 3. We put that as a positive exponents. We have 2592 over x3 plus 12 as our d squared s over dx squared. That's the first part of question D. But first it asks us to find, which we've done. And then it says, hence, show that the value of x found in part C gives a minimum value. So we're doing the second derivative test for min or max. The second derivative test for min or max is you sub your x value into the second derivative. And if the second derivative is positive, then your curve would look like this, smiley face for positive. Then we have a min value. And if your second derivative is negative, then we would have a max value. So we just need to see for min value, we want this situation, we want it to be positive. Let's take a look. All we do is sub in x equals to 6. And therefore 2592 over 6 to the power of 3 plus 12. Quick calculator work. This comes to 36, which is positive, therefore min value. Okay, so it's a minimum value, and that's your proof, your second derivative test for proof. That was question 2D. Question 2E. Finally, they get to the last part of these sorts of questions, which is always to find the minimum surface area that the brick can possibly have. And we do that in order to find the minimum surface area. We for minimum area, you sub your x value, the x value that you got from working out the second derivative equal to 0, into the original formula. the original formula for area, which in this case was S, our S formula. So it's a nice relaxed end to question 2. We find our S formula, which we previously worked out over there, and we sub in. So our surface area is going to be 6, subbing x equals to 6 into the equation, into the formula, 2592 over 6. This comes to 648, and just check that you're working in the correct units. I think we were working in centimeters, and for area, it's centimeters squared. And that concludes question 2.